Hello and welcome to another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler and today we'll be doing Unit number 5, Lesson number 4 on the point-slope form of a line. Now for many of you, this is going to be a brand new topic. Some of you may have gotten introduced to the point-slope form of a line back in Common Core Algebra 1. But for many of you, this will be the first time that you're seeing it. Now in the last lesson, we reviewed what was called the slope-intercept form of a line. Today, we're going to see a different way to write the equation of a line that will be particularly useful in this course and in future courses as you move on. So let's jump right into it. All right. There are two primary forms of a line. One of them, which we reviewed in the last lesson, was the slope-intercept form. Right? And the idea was that you had the slope of a line, the change in y over the change in x. You had the y-intercept of the line, which for some inexplicable reason we use the letter b to represent. And putting those together, you get y equals mx plus b. The point slope of a line, similar to the slope-intercept, will again involve the slope of the line, but it will then involve just some random point lying on the line. Somehow, knowing the slope and some just arbitrary point on the line, we'll be able to write the equation of the line. Now, it probably isn't overly surprising because if you think about it, if I gave you a point and I gave you the slope of a line, you could then draw that line, right, by kind of going forwards and backwards from that point according to what the slope told you. So there is a form of an equation of a line that kind of represents that. And what we're going to do in the first exercise is we're going to sort of get at what that form looks like and why it looks like it. So let's jump right into exercise number 1. All right, let's take a look. Exercise number 1, we want to explore a line whose slope is 2/3 and which passes through the point 4, 5. Letter A, on the grid below, draw the line. The point 4, 5 has already been plotted. All right, so what I'd like you to do is take a few moments, given that you know the slope is 2/3 and you know it passes through the point 4, 5, go ahead and graph that line. Don't worry about what its equation is, just plot the points and connect them with a straight line. All right, let's go through it quickly. We know that the slope is 2/3. And we know that that then represents a rise, that almost looks like an R, a vice, divided by a run. Let me actually change that into something that looks like an R, kind of. All right, anyway, so if I do a run of 3 and a rise of 2, I have that point. Likewise, a run of 3 and a rise of 2. I get this point, maybe I'll go a little bit backwards. Right? Get some more points, etc. That's enough. All right, and something like a ruler that you can make longer whenever you need to. And there is my line. All right, great. Wonderful. Let's take a look at letter B. Between what two consecutive integers, consecutive meaning things like 4, 5, 9, 10, 13, 14, between what two consecutive integers must the y-intercept of this line fall? Now, this should be easy enough. Between what two consecutive integers does the y-intercept of this line fall? Well, the y-intercept is right here, and it's not a particularly nice number. Whatever it is, it's not a whole number, right? But it does fall between 2 and 3. But it is neither 2 nor 3. So if we were going to go with the slope-intercept form of the line, y equals mx plus b, it would be fairly difficult to write its equation right now because that thing is a messy number. We could eventually solve for it using some algebra, but we're not going to do that right now. A little bit later on. Okay, let's take a look at letter C. The point -8, -3, which is right here, and lies on this line. Find the slope between negative 8, 3 and 4, 5 using the slope formula. Why does this answer make sense? So go ahead, take this point and this point, use the slope formula, and calculate the slope of the line that we just plotted. All right, let's go through it. So, little review. y2 minus y1 divided by x2 minus x1, 5 minus negative 3, all divided by 4 minus negative 8, gives me positive 8 in the numerator, positive 12 in the denominator, and again, always reduce your slopes. So I'll divide both of these by 4, and I'll get a slope of 2/3. Why does this answer make sense? Because the slope of a line is the same no matter which 2 points you pick. Whoops, that's not what I wanted. Just wanted to move that out. Pick to calculate it. All right, now I want to just for a moment get rid of that, or at least move it somewhere. Great. This is a very important point. This isn't like just some random thing. This is going to segue into the point-slope form of a line. You see, starting off, we knew that the slope of this line was 2/3. That's what we used to plot the line, okay? And then I just sort of randomly picked 2 points off of it, the negative 8, negative 3, and the one that we knew to begin with, the 4, 5. Okay? And what we found was when we went through the slope formula, ultimately speaking, right, we got the same slope. Now I could pick this point and this point, I could pick this point and this point, this point and this point. Any 2 points that I pick on this line, if I do y2 minus y1 divided by x2 minus x1, I've got to get 2/3. In fact, if I pick 2 points off on this line and I don't get 2/3, then I either did the slope calculation wrong, or this isn't a line, all right? A line has the same rise over run no matter which 2 points you pick off of it. And that is the key to the last part of this problem. Letter D. Consider any arbitrary point x, y that lies on this line. Okay, so this is important. So we've got this line with a ton of stuff circled on it and stuff like that. And I'm in red, so I'm gonna stick with it. So let's say I just grab some what's called arbitrary point. Okay, and I'm gonna call it x, y because it is truly arbitrary, meaning that it could be anything. All right, explain why the following equation, this one, must always be true for this line. Then rearrange the equation so there is no fraction on the left-hand side. This is known as the point-slope form of the line. Okay, so if I've got this line, since it's way up here, we can't see it, so let me just, if I've got this line, and I've got the point 4, 5, and I have some other point that I'm calling x, y, why does that equation have to be true? Well, it must be true because it is simply saying that the slope between 4, 5 and x, y is 2/3. That's it, right? y2 minus y1 over x2 minus x1 is 2/3 on this line. You know, on other lines that wouldn't be the case, but on this line, if I pick any point xy off of it, and I calculate the slope between this point and this point, I must get 2/3. And therefore, right, I can now take this thing and rearrange it a little bit to get rid of the fraction. Let me extend the page a little bit. Okay, so I'm going to take this thing and bring it over here. Okay, so how do I get rid of this fraction? Well, what I'm going to do, I'm going to give myself a little bit of space here, is I'm going to multiply both sides of this fraction by x minus 4. Okay? So in other words, I want to get rid of the fraction, which means I really want to get rid of the denominator in the fraction. So since I'm dividing by x minus 4, I just multiply by x minus 4 on both sides, and I get the following. Y minus 5 equals 2/3 times x minus 4. Let me really just circle that guy, because that is known as the point-slope form of this line. Why? Because you can see the slope, 2/3, and you can see a point, 4, 5. All right? Don't worry, we're going to come back to that. All right, but let's finish off this problem. Letter E. Rearrange the point-slope form of the line from D and place it in slope-intercept form. What is the value of the y-intercept? So, again, lots more work, obviously, in this lesson, but point-slope form was y minus 5 equals 2/3 times x minus 4. What I want to do is I want to now take this and get it to look like this. All right? So what I'd like you to do is take a few minutes, granted there's a fraction multiplication involved, but see, and fraction addition, see if you can rearrange this into that, and then we'll take a look at it. All right, let me go through it. We're going to be doing this quite a bit today. Extend the page a little bit. Well, the first thing I can do is multiply through by 2/3. So I get y minus 5 equals 2/3 x minus 8/3. So 2/3 times 4 is 8/3. I can now add 5 to both sides, and I'll get y equals 2/3 x. Now maybe I'll do a little bit of fraction work with you. Let's combine those, so that could be 2/3 x minus 8/3 plus 15/3. So y equals 2/3 x plus 7/3. And what was its, whoops, let me, no, get rid of this so you can see it a little bit better. Right? Y equals 2/3 x plus 7/3. That's y equals mx plus b. The y-intercept was 7/3. If I write that as a mixed number, that's 2 1/3. Remember back up above when we talked about between what two consecutive integers must the y-intercept fall? Between 2 and 3. Well, in fact, it is exactly 2 1/3 or 7/3. All right. Now, this introductory exercise really just goes to show you where the point-slope form of a line comes from. But it hardly gives you any kind of practice or fluency in the point-slope form. So let's talk about what point-slope form really is. All right. So whenever we have a line that has a slope of m, we'll keep that as the letter, and it passes through some point x1, y1. Notice it doesn't say xy, it's x1, y1. Whenever you have subscripts like this, what that means is it's a specific point we know, okay? Anyway, without the subscripts, then they're just kind of generic variables. But we've got a slope m, it passes through the point x1, y1. then this equation, y minus y1 equals m times x minus x1, will be the point-slope form of a line. So again, I've got this line. Let's say I know its slope, change in y over change in x. Let's say I know this point that lies on it, x1, y1. Then what we get is this equation. Y minus y1 equals m times x minus x1. Okay? Now it's very easy to use. And again, it all comes from the fact that had I not rearranged it, I would have had something like this. In other words, I've got a point that I know, I've got a slope that I know, and then I've got all the other points I don't know, x comma y. Rearranging them, I can get this point-slope form of the line. It is very easy to use the point-slope form, so let's jump right into it now and get some practice. All right, using point-slope form, write equations of the lines that have the following slopes and points. Now, this is very mechanical. It's literally like, here's the slope, here's the point, write the equation. All right, so let me do a couple of them with you, and then have you do the last two on your own. So first things first, let's jump into letter A. All right, the point-slope form of a line will always look like this. All right, where this is my x1, y1. So literally, it's plug and chug. It's y minus 7 equals 4 times x minus 5. And that's it. I'm done. Okay? You might feel like you need to distribute the 4, add the 7, do something like that, but I don't have to. I would have to do that if I was trying to rearrange it into slope-intercept form, y equals mx plus b. I don't have to here, right? That's as good of an equation as any other. Let's do letter B together. So again, same idea. We've got the slope, nothing tricky there. Here I'm going to call it x1, y1. Now there is something a little bit strange that happens in this one, so let's show you. I've got y minus y1 equals m times x minus x1. And it's specifically this that's a little bit funny. Okay, now you could, in theory, leave the equation of the line like this. I will say though, if this was a multiple choice question on a test, they would never leave the equation of the line like that. They would take that double negative and they'd make it into a positive. In other words, this would be how they would write their final answer. Okay? So what I'd like you to do is try C and D. This is a real plug and chug kind of procedure. All right, are you ready to go through them? Let's do it. So let me do this. I'm going to totally run out of space. All right, here we go. Y minus negative 10 equals negative 2 times x minus 4. Telling you. I have to write very thin in that last one. Just like before, although it would be mildly acceptable to leave it like this double negative we can easily turn into a positive and have y plus 10 equals negative 2 times x minus 4. Okay, so simple enough. Likewise, let's do the last one. So I'm going to get y minus negative 5 equals 4/5 times x minus negative 2. Ooh, just barely fit it in there. Changing those double negatives to positive, y plus 5 equals 4/5 times x plus 2. Now, for those of you that feel comfortable with the double negative issue, and that's probably many of you, you might have the question, do I really have to show this first step? Or if I know that it's y minus negative 5, could I just immediately write down y plus 5? And the answer to that, in my opinion, is absolutely you can do that. That's no problem at all. In fact, I'll probably lapse and do that on occasion. It is always subtraction, but when you subtract a negative, of course, you end up just having that addition of a positive. Anyway, let me step out of the way right now in case you need to write down any of these 4 answers and how we got there, and then we'll move on and we'll use the point-slope form a little bit. All right, let's do it. It's an exceptionally nice form of the line, especially if you know the point and you know the slope. Now, what's kind of cool is that the equation of a line is really the equation of a line. Whether it's in slope-intercept or point-slope, they really are the same equation. They're just maybe written in slightly different forms, okay? Many times we can use the point-slope form to then figure out the slope-intercept form. We actually did that in exercise number 1, but let's take a look at it a little bit more formally in exercise number 3. All right, which of the following is the equation of a line that is parallel to this and passes through the point here? Now, the key on this is that all of these different equations are in slope-intercept form. But because I'm given a point that lies on this line, and I'm sort of given the slope of this line, we'll talk about that in a minute, then it's going to be easiest to first write it, in my opinion, in point-slope form. So, first things first, right? What is the slope of my line, right? If my line is parallel to y equals 5x minus 3, what is the slope of the line I'm looking for? Well, hopefully, you say 5, right? So the slope of the parallel line, that was supposed to be the parallel symbol, doesn't really look like it, looks like a 4. The slope of the parallel line is equal to 5, right? Remember, when I look at this, I got to immediately know slope is 5, y-intercept is negative 3. Well, the y-intercept being negative 3 is irrelevant. So now I have the slope of a line, and I have a point that lies on it. So I could write the equation of the line in that point-slope form as follows. Y minus 11, y minus y1, let me write that up, equals m times x minus x1. So I have y minus 11 is 5 times x minus 4. Now, if that is one of these 4 choices, then you immediately write it down. But be careful. It would be tempting to think it's choice 1 because there's a 5 and there's an 11, and up here there's a 5 and 11. But look, that thing and that thing, they don't look the same. They might have some of the same elements, but they don't look the same. Right? So now let me work on this a little bit. One thing I can do is use the distributive property to distribute that 5 through the parentheses, and I would get something like that, right? And then I can get rid of the negative 11 by adding 11 to both sides, and I'll get y equals 5x minus 9. And that is obviously choice 2. All right? Again, what this goes to show you is that sometimes, even though we may be looking for a slope-intercept form, y equals mx plus b, we can get at that by first more easily writing down the point-slope form, y minus y1 equals m times x minus x1, and then doing some kind of simple algebra to rearrange it. All right? Let me step out of the way, copy down anything you need to, then let's move on. All right, let's do it. Exercise number 4, a little bit more involved here. Segment AB has endpoints at negative 4, 9 and at 0, 1. If a line is drawn through A, that's important, that is perpendicular to AB, what is its equation? What would its y-intercept be? Okay, now there's no mention in this problem of point slope or slope intercept, whatever. So when we come up with the equation of this line, we could write it in either form, okay? What I'd like you to do now, though, is pause the video and take some time to work on this problem. All right. Well, key to writing the equation of any line, whether it's slope-intercept or point-slope, we need the slope of the line. Now, I can use the slope formula to figure out the slope of AB. Let's do that really quickly. So for AB, the slope is going to be 1 minus 9, the change in y, 0 minus negative 4, the change in x. So that's going to be negative 8 in the numerator, positive 4 in the denominator, for a slope of negative 2 over 1, or just negative 2. Now that's the slope of line segment AB. But I need a line that is perpendicular to AB. And therefore the slope of the line that I care about is going to be a positive 1/2, right? Negative reciprocal slopes, positive 1/2. So now I'm all set in writing the equation of my mystery line, so to speak. Remember, I'm not looking for the equation of AB. I'm looking for the equation of a line that passes through A and is perpendicular to AB. So what do I know? Well, I know a point that lies on my line, and I know the slope of the line. So it's very easy to use point-slope form, right? Using this as my x1, y1. So I'll do y minus 9 is equal to 1/2 times x minus a negative 4. Again, I'm going to take that double negative and I'm going to change it to a positive. And that is a perfectly good response to the first question this problem asks. What is the equation of this line? Y minus 9 equals 1/2 times x plus 4. What it's not a good answer to is what its y-intercept would be. To do that, it would make sense now to rearrange this into y equals mx plus b form to be able to identify b. So let's do it, and we'll finish off the lesson. All right, I think I'll try to put all that work right over here. I think I can squeeze it in. Y minus 9 equals 1/2 times x plus 4. The first thing I'm going to do is distribute the 1/2. Nothing happens on the left-hand side. Y minus 9 equals 1/2 x plus 2. I can now add 9 to both sides, and I'll get y equals 1/2 x plus 11, which means my y-intercept must be 11. Okay? Again, either this or this would be completely acceptable for the question, or for the answer of what is the equation of this line. On the other hand, what is the y-intercept? Only that one is the correct answer. Because of course that's not the equation of the line, that's just the y-coordinate where the line cuts through the y-axis. All right, let me step back, give you a moment to think about this, and then we'll wrap up the lesson. All right, let's do it. So for years and years, you've been seeing y equals mx plus b, the slope-intercept form of a line. You've learned many, many times how to identify the slope and the y-intercept based on looking at that equation. Today, maybe for the first time ever, you saw a new form of a line called the point-slope form of a line. Now, if your teacher showed you this in Common Core Algebra 1 or in previous years, that's great. Use that knowledge, run with it. In this lesson, we tried to show you the key to how to understand that equation, and of course, or that form of the equation, which is really all about the fact that if you know a point and then you have an arbitrary point, doing rise over run between the two has to give you this slope value. At the end of the day, most people kind of forget that that's where it comes from, and they just sort of memorize y minus y1 equals m times x minus x1. We're going to have lots of opportunities in coming lessons to use that form of the line and get a lot of good practice with it. For now, I just want to thank you for joining me for another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.